Greetings from Aditya University and warm good evening, one and all. Today, we welcome you for the third day certification course on emerging trends on research in electrical engineering. Before going to start our lecture, let us have a brief let us have a brief review on the previous day topics. In the previous class session, we have discussed about load frequency control, in which various generating solutions are equipped, that is, the thermal power plant and renewable energy sources such as wind and solar are also considered in this. So now, based upon those things, we are moving on to the virtual power plant concept with the help of the future of green energy. Today, the topic is for today's lecture. The topic is uh, the perspective of virtual power plant, that is, future of green energy grids. What is the need of green energy? We all know that with the extensive emission of with the extensive use of fossil fuels, they are getting depleted. Fossil fuels such as coal is mainly used for the power generation, that is thermal power plant power generation. With the help of thermal power plant, we are generating energy. Apart from thermal, we are also using nuclear power plants, which uses nuclear reactors, that means uranium and thorium. We are using with the help of those elements, we are generating energy. So with the extensive use of that nuclear power plants and thermal power plants, our fossil fuels are getting day by day, are getting depleted day by day. Apart from that, from this conventional power plants, large amounts of carbons are emitting into the atmosphere. Due to this, our ozone layer is getting depleted, which is having hard effects, which is having side effects, and also the global warming is occurring. So, in order to reduce this part, we are going for green energy. And we know that green energy is nothing but the energy coming from renewable energy sources. Renewable energy sources such as solar and wind, we are mainly focusing on because the wind and solar are freely abundantly available in nature. And also, with the help of that, we can generate huge amounts of energy and earn profits. And from the coming to the today's topic, we have came across the word virtual. Another part is power plant. Yesterday we have discussed about thermal power plant and realistic the solar thermal system power plant and other things. But today we are discussing about virtual power plant. So virtual power plant in the sense it is a combination of one or more generating stations in order to generate electricity and supply surplus energy to the grid in such a way that the user can get benefited in order to earn profits. Okay. Now let us move on to topics. So it consists of a general introduction, components of a virtual power plant, that is VPP, and classification of virtual power plant, energy management systems, and how VPP is different from microgrids, and also research on VPP and a case study on VPP. Okay. Now, before going to detail, we will be looking into this diagram. As I stated earlier, the virtual power plant means it's a combination of one or more energy sources. If you observe this diagram, here the wind power plant, we have considered wind power plant is one system, and another wind turbine also we have considered. Apart from wind, we are generating energy from conventional power plant, and also here biomass power plant we have considered. Here hydropower plant, which is acting as a base load, and apart from that, as I stated earlier, the energy from solar also we are considering, and also we are selling the energy to the grid. Okay, and the thing we have observed in this virtual power plant is all the energy that is developed by wind, solar, biomass, and hydro and solar power plant is continuously be monitored at the control center. That means this control center sends signal to the renewable energy sources in such a way that the maximum amount of energy can be extracted. For example, let us consider the energy from solar or wind. Let us take an example from solar. So from solar, the energy is available during daytime, but peak hours will be in the night time. So the energy is generated during daytime and it is to be utilized during night time. In order to do this part, we are we are implementing the energy storage with battery storage systems. Okay, these battery storage systems connected to the grid and they will store the energy from the solar panels. Okay, and they will be storing energy from the solar panels, and after storing it, we will be using this energy during peak hours. This can be implemented with the help of control signals, which are being sent by the control center. And apart from that, here you can observe the load demand forecast. The load demand forecast, in the sense, we are forecasting the energy. That means we are calculating what amount of energy we will be required for today or else for tomorrow maybe after 1 week. So as we all know that the population growth is increasing day by day. With the increase in population growth and with the advancement in technology, the power consumption has been increasing tremendously day by day. So in order to calculate the what amount of power is required for the next coming days, we are doing this forecasting method. So in load forecasting, we will be forecasting energy for a day. That means we can take energy from 0 to 24 hours. Okay, and on x-axis it is load. So that means we can forecast energy from 0 to 24 hours. Or else in some of the research articles, they have done for an year. That means 0 to 8460 hours. And on the x-axis, on the y-axis, it is load in kilowatt or megawatt. Okay. So the load curve, they are calculating it for a day or for an year also they are calculating it. So, so let us take an example that today they have calculated the load curve and they are having the yesterday's load curve also. Depending upon the today's and yesterday's load curve, apart from today and yesterday's load curve, we will be having the data of previous year also. So with the help of previous year's load curve data, yesterday, today's load curve data, and we are calculating it, the upcoming data, that means upcoming tomorrow's or day after tomorrow's load data with the help of some artificial intelligence techniques. Okay. So for this, we will be using some meta-heuristic optimization techniques. We will be discussing on tomorrow. And apart from that, load forecast, here power generation forecast is also there. That means we are going to forecast the amount of energy that is being generated by the power stations. For example, today we have installed a solar power capacity of about 100 megawatts. Okay. In order to earn profits for us, maybe for tomorrow or day after tomorrow, another company has come into the market and they have installed some amount of solar panels, and with that they are generating more amount of energy, and they're trying to sell the energy at low cost. Are you getting the point? So that means we are forecasting the energy generation, and also with the increase in population, we are supposed to increase the generation also. So based upon that, the new companies will be coming into the market and they are selling the energy to the grid in such a way that they are earning the profits. And the next one is energy price forecast. So if you look into this concept, energy price forecast, that means the amount of energy which we are getting is uh, given by load curve, and the load curve multiplied with time is and the load curve that is multiplied with unit price is called the energy price. So the energy price is not same in all the days, especially for industries. You will be selling around 10 rupees per unit. Okay, for it is commercial buildings around 8 to 10 rupees per unit. And if it's for residential buildings, the energy per unit will be around 5 rupees per unit. And also, this this unit consumption rate is not same throughout the hours. It may be varying. For example, if you take a load curve, okay, if you assume as this is a load curve time t in x-axis and power in kilowatt or megawatt on y-axis, this part is called as peak load curve. Okay, that means the amount of energy which we are utilizing it during the peak hours is very much high in cost when compared with low peak hours. Okay, are you getting the point? That means during peak hours, the amount of electricity bill we are getting is very much high when compared with off peak hours. Okay, so this is about energy, and also we are forecasting the energy price. That means we are predicting the energy price in the future. That means maybe in tomorrow what will be electricity generation and what will be its price, and day after tomorrow what will be the load consumption, and multiplied with some unit rupees, we will be getting the tomorrow's load energy curve cost. So based upon that, we are forecasting the energy of the electricity consumption. Okay. Next, followed by the elements in virtual power plant. If you observe this diagram, here earlier I have told you that the virtual power plant, it is a combination of number of energy generators. That means here you can observe it. Here we have considered renewable energy sources, and here we have given it as a power system. That means the power system means it consists normal generating stations and load and base load power plants will be there in the power system. And apart from that, here consumers are there. Consumers means we will be getting three types of consumers mainly. First one is residential, which we will be using for household appliances. Next one is commercial consumers. That means shopping malls, exhibitions kind of thing, and etc. And the third one is industries. So in general, the consumers are divided into three categories: residential, commercial, and industrial. Where the industrial and commercial load consumption is very high when compared with residential consumptions, because in industries, a huge amount of power is required to run a high capacity megawatt machines. And apart from that, in our virtual power plant, energy storage devices are also integrated. As I have stated earlier, the power generated by the wind or solar systems is to be stored. The reason is our household appliances are generating power in AC. Sorry, are utilizing the power in AC. Whereas with conventional power generation, which is of AC, but the power generated by solar PV panels is solar is DC. And whereas with wind also, the power generated is AC, but it is having some harmonics. So these harmonics can be neglected with the help of converter and inverter technologies. Whereas in DC solar power, which is of DC type, we are supposed to connect it to battery. Okay, and this battery, it will be storing the energy. Even the energy generated by the wind, it can be stored in the battery systems, and we can use it during off-peak hours. Here I have given an example of electric vehicles. I think you can clearly see it. Electric vehicle. This electric vehicle gets charged during off-peak hours, and during peak hours, we can consume or take the energy from the electric vehicle in such a way that the owner of this electric vehicle can earn maximum amount of profits. Okay, and the next one is DER. The next element is DER. DER in the sense distributed energy resources. That means it may contain a conventional power plant and renewable power plant, whereas microgrids also can be coming under this distributed energy resources. Some examples of distributed energy sources are thermal power plant, wind turbine systems, solar power plants, biogas, biothermal, hydel, and tidal systems, ocean thermal energy conversion. All this comes under this distributed energy resources, and the power generated by this distributed energy resources will be controlled with the ICT control system. Next one is ICT control, ICT technology. ICT means information communication technology. Sorry, communication transfer technology. Here we are giving, with the help of this ICT, we are transferring signals in such a way that so and so wind system is to be not so and so system is to be on, or else so and so system with the load is to be on. That means the high capacity load system during is to be off during peak hours, and low capacity system should be on during peak hours, kind of thing like that. We are giving signals in such a way that the loads will be operated with the help of demand-side management techniques, which sends signals with the help of this ICT technology. Okay, now let us move on to the next one. Here I have given a brief definition of it. You can observe it here. A virtual power plant is a network of power generating units with flexible power consumers and storage devices. Okay. The main advantage of this virtual power plant is it reduces the amount of fossil fuels, especially the coal power generation. And also, with the help of these green energy sources, we are generating a sustainable energy from sustainable energy than conventional power plant like wind, conventional power plant like thermal systems. And the main objectives of the virtual power plant are to increase the network of the distributed energy systems. Earlier, that means earlier in the previous case, we have a centralized network system, which you can observe in this. Now, with the help of this virtual power plant, we will be having the decentralized network system. So, if you observe the difference between these things, now see, you can observe this one, yesterday's part. Let's here we have given yesterday. That means a conventional power system where larger power plants are utilized, and these power plants will be able to generate energy from coal. Okay, from coal and nuclear power plants. With the help of this, we are generating energy, and the amount of generation which we are generating is directly distributed to market, which is centralized market, especially mostly by nation. That means our government is providing energy to us with the help of the towers and the pipeline. That means the towers used for overhead transmission systems, and these pipelines will be used for underground transmission systems. Okay, and the other thing is it's a one-way communication exchange. That means from the source, that is from the power generating stations, we are directly getting energy. Only one-way source, no two-way source of information exchange or two-way source of energy exchange hasn't been taking place. Only one-way distribution is will be in the conventional system. And apart from that, we, the residential users or the consumers, we will be only paying the money to the government. Whereas in decentralized system, we the consumers may be paying the money and also receive the money from the government. That technique I will be discussing now. Okay, are you getting it? In conventional, that means in centralized network, the energy generated by the power plants will be directly sent, will be transferred with the help of towers for overhead transmission lines and underground cables. And from that, we'll be receiving the household appliances or consumers will be receiving energy. And for that amount of energy, we are paying the money. Whereas this decentralized network, okay, decentralized network, which is of virtual power plant, it consists of number of energy sources. Here you may see that first one we have considered it as wind turbine systems, and the next one is solar power plant, and the third one is uh, parabolic solar power plants, and this is a plain solar power plants. Many small generating stations have been introduced in our decentralized market. And this decentralized market, sorry, decentralized system, the market will be consisting of various kinds of companies, that has generation companies, transmission companies, and distribution companies. Regarding these companies, we have discussed it on yesterday very briefly, and these companies will follow some rules and regulations. That means, let us assume a company, a generation transmission distribution company of 1 and GDD company of 2. Okay. Now here he will say that one will say that I will sell an amount of unit charge of energy as 10 rupees. And another company will be saying that he will sell an amount of energy for 9 rupees. Now we the consumers will have an option to choose the energy from any one of them. That means like Southern Distribution Company, Southeastern Distribution Power Plant Company kind of thing. Okay. So like that, here number of market players will be there. So if you observe this one, even the market players also there will be interconnection in such a way that the amount of energy can be easily distributed among all the companies. See here, one network to another network, we are having interconnection, and this network to another network, we are having another interconnection. Whereas this kind of interconnection network is not available in a centralized network. Okay, let us erase these things. Okay, see now here you can see that in a decentralized one, everyone is having interlink. Whereas in centralized network, no interlink among the consumers or market suppliers is will be there. And apart from that, conventional derivative system is having a long transmission lines for the overhead transmission and underground cables for the underground transmission, and also the battery energy sources are coming into picture. Whereas in conventional or centralized power stations, the battery storage devices are not considered. Here you can assume it as an electric vehicle system or else a battery storage device which stores energy from solar PV cells or wind turbine systems, and they will be storing energy in off-peak hours and selling the energy during peak hours. So here in decentralized system, the batteries will be considered. Okay. Apart from that, coming to the distribution part of thing, the energy which is generated with the help of decentralized technology will be having a two-way transfer. So if you observe this area, one we are getting, we are consuming the energy, and another one we are selling the energy. Okay, how we are selling? We are consuming the energy in the sense it is in a conventional way, but here you can see that we are selling the energy. How we will be selling the energy? Let us discuss these things. Let us assume, or else we can observe that, or many of the colleges or industries or household users have installed the solar power plants, solar panels on the rooftops. It isn't it? So after installation, they won't be getting idle. They won't be sitting idle. After installation solar power, they will be getting some amount of energy, in which this amount of energy can be stored in the battery and can be utilized for our household appliances, or else we can sell this amount of energy directly to the grid. Are you getting the point? Let us take this, and this is a greenhouse where solar panels are mounted on this house. So here itself only for this house, the amount of energy which is required, we are generating energy. After generating the energy, the excess amount of energy can be again sent back to the grid. This thing, the two-way communication, that means two-way transfer of energy will be existing in the decentralized system. Okay, two-way transfer of energy. Another thing is two-way communication also. Here, previously here only one communication, that is from generation stations we are getting energy. Whereas in decentralized market, number of energy sources will be there. This ICT, previously we have seen that ICT technology will send signals in such a way that which system is to be on for delivering energy and which system to be on for the energy consumption should be off for the energy consumption in such a way that the system may not lose its stability and should be maintained at nominal values. Here also the battery storage will be existing because the considered house is a greenhouse. Okay, so let us move on to the next one. Next objective. The next objective is to monitor and forecast and optimize the trade power. So if you observe the first point, monitor. So monitoring in the sense the amount of energy that is being generated by the generating stations such as thermal or renewable energy sources. The energy generated by the renewable energy sources is intermittent in nature. That means it is not intermittent. That means the energy generated is not constant throughout the day. For example, if you take a solar system, the solar radiation is very much high in daytime when compared with nighttime. So during daytime, the solar energy generation is very much high when compared with nighttime energy consumption. Even in the winds also, during a windy day only, the wind energy generated will be very much high when compared with the off windy days. So the energy generated by the renewable energy source is intermittent in nature. So the thing is, we need to monitor the devices and also note down the amount of energy being generated by the generating stations and generating stations and also the load consumption patterns also. Apart from that energy and load, here we need to monitor the devices, whether they are in working condition or not. All the things we are supposed to note down. That means we are supposed to monitor and should be noted down. Next one is forecast. Forecast in the sense we are supposed to predict the amount of energy being generated today or else the amount of energy which that is to be required for today. That means we need to forecast 1 day ahead or 2 day ahead. If you observe the demand side management technique, okay, demand side management technique, there many literatures have been stated saying that they have used 1 year ahead forecasting techniques or else they have used 1 day ahead also. That means within the 1 day or 2 day, they're forecasting the amount of energy required and based upon that, they're scheduling the devices. Okay. Next one is optimize. Okay. Let us take an example of our household. Let us assume, yeah, our household with an automated device of room cleaning robot, automatic dishwasher, and the washing machine. Let us assume these three: room cleaning device robot, automatic dishwasher, and washing machine. These three things can be turned on and off without our human without manually. So the thing is, if we use these things, use three machines during off peak hours, okay, we can get we can save more amount of energy. Understanding? If we use these three automatic devices during off peak hours, we can save more amount of energy and also electricity bill can be saved. If we use these three things during peak load means during peak load generally the price will be very high in such a way that we will be getting huge amount of electricity bill. So this is maybe one of the example. And the another example is we need to optimize the devices in such a way that the energy consumption should be very low and also the maximum profits is to be attained. For that purpose, this optimization techniques will be utilized. And the next one is trade power. We need to sell the power in such a way that the consumer has to get more amount of profits. So for this, I have shown here a diagram. Here you can see that a data hub is there. In this data hub, many equipments are connected. First one is the generating side. Okay, the renewable power generation and power system market, that is ISO. that means independent system operator, where different kinds of companies such as transmission company, distribution company, and generation company will be there, where the market will be with the help of the market, this IOPS operator will be sending bids in such a way that we will be getting the degraded environment and also the consumer loans. So there he will be getting one information. Next one is weather data. Based upon the weather, we are forecasting the load consumption. Sorry, based upon the weather, we are forecasting the amount of power that can be generated from solar and wind systems. Apart from that, clients and trades. Clients in the sense, this may be the industrial or commercial or residential clients which they require amount of power. And the next one is API service, protocol service, QR visualization, that means monitoring purpose it used to be there, and QR term and optimization trading. Here, this optimization trading means in such a way that the energy consumption should be reduced and electricity bill is also reduced, and also optimization is required in such a way that we, the consumers, while selling power, has to earn more number of profits. Okay. Next one is AI featuring data processing devices. So if you observe this one here, I have given example of the amount of wind, the yellow color part is of wind, and green color, yellow color part is of solar, and green color part is of wind, and the black color part, this part is of battery saver. So here we can observe that here during a period of day, that means a total of 24 hours, the amount of power that is being generated by solar, wind, battery, natural gas, coal, nuclear, and coal power plants, we have forecasted it here. So these three are the base load power plants. You can observe it here. First one is coal, next one is nuclear, another one is coal with nuclear gas. So you can observe that this curve is almost straight line. Apart from that, this is the power that is being generated by our renewable energy sources, and this is the load forecasted. That means the power forecasting. This is the power forecasting curve. Coming to the next objective, to balance the fluctuations in power generation. So, like in the previous class, we have discussed about the automatic generation control system. Okay, in automatic generation control system, the main objective of this AGC is to maintain the system stable in stable condition in such a way that the the system values such as deviation in frequency delta F and deviation in tie-line power del P tie should vary in the nominal values. For example, the frequency of at Indian standard is 50 Hz. The frequency at Indian standard is 50 Hz, whereas in European countries the frequency is 60 Hz. During Diwalis or during festival days, there will be sudden rise in load consumption. Due to this sudden rise, our system may lose its frequency from 50 Hz to 49.5 or 49.14 kind of thing. But the thing is, with an immediate effect, this frequency has to come back to initial condition. So this can be done by the load frequency control, that means primary control of the AGC system. But here also we can generate this thing. We can observe this, and that means to balance the power fluctuations. Balance in the sense the amount of power that is being generated should be equal to power demand plus loss. This equation should be balanced. Okay. So for that example, I have considered a simple three-area system in which thermal system is considered in all the three areas, and also the peak amount load is generated by renewable energy, that is parabolic solar thermal power plant and realistic distillation solar thermal power plant. Here, these base load power plants are enhanced with supply with realistic with the renewable energy sources. So if you observe these graphs, where the first one is deviation in frequency and the second one is deviation in tie power. If you observe in both the cases, the red color one is with implementation of with integration of renewable energy sources, whereas the black color one is without renewable energy, that means with thermal system only. The black color, the response with the black color are thermal system responses, and whereas the responses with the red color one are thermal with renewable energy sources. So in both the cases, you can observe that when the renewable energy sources are integrated to our system is showing better responses in terms of first one peak overshoot. Okay, so in both the areas, you can observe that the peak overshoot is very high for black, and for red, the peak overshoot is very less. Whereas the peak undershoot, The peak undershoot values also, here you can observe that in delta F1, that means deviation frequency also is very high when compared with the system without renewables. Whereas in tie line power also, the peak undershoot deviation is very high. And coming to the settling time, okay, the red color one, that is settling very quickly over the system without renewable energy sources. Similarly, in the case of in the case of type of deviations also, the red color one, okay, is with the system with renewable energy sources, that is reducing very settling very fastly over the conventional system. So this is the third objective with our virtual power plants. Okay, come to the next one. As I've told earlier, the heterogeneous generation VPPs increase the profits and flexibility. So how we going to increase the profits means we will be selling the energy in such a way that means in VPPs many small energy sources are installed. So with this small sources, we are selling our energy to the grid. So such a way that we will be getting profits. Okay. Apart from profits, flexibility also. That means we can get the energy from the market, from the markets where we will be we can be get the low cost energy. Okay. So general in markets there will be many providers which will be at many costs. That means different operating costs. But we can get the energy at the our flexibility in such a way that low operating costs will be getting. And the next one is we are having BPPs. We will be having a centralized control system in such a way that maximum profits can be earned. And in the Phoenix project, they have given me a formula. It is a virtual power plant that aggregates the capacity of many diverse distributed energy resources. Okay. And also, this VPP, virtual power plant, it offers services to a system operator, that means ISO system operator. Apart from that, this VPP, that means virtual power plant, is almost same as autonomous microgrid. Okay. A microgrid means a small generating station where the energy is selected to the grid. And also, the VPP will be considered as a single generating system also. Okay. And apart from that, the virtual power plant is having some its own characteristics. First one is scheduled outputs. That means we can tune the systems in such a way that the output can be scheduled. That means the output of the generating station or the output of the loads can be scheduled. And also the ramp rates. That means all of a sudden disturbances or sudden rise in peaks. That means the load consumption is of sudden rise. We can get it stimulated or stability condition with the help of this virtual power plants. And also the generation limits. That means the amount of power that being generated by the generating stations will be under some certain conditions. Let us take a power plant P1, okay, that is generating a power of around 40 megawatts. For this generating station, the minimum is 20 megawatts and the maximum is around 60 megawatts. That means this is the minimum limit and this is the maximum limit. Our BPP is giving instructions in such a way that we will be getting the maximum amount of energy with less losses so that it cannot go beyond 20 megawatts and above 60 megawatts. Next one is operating costs. The operating costs means we have discussed earlier. We will be getting the less amount of energy at low cost. Next one is voltage regulation capability. The voltage regulation means the voltage regulation will be very less in such a way that there won't be any difference between sending end voltage and the receiving end voltage. And also reserve capacity. Okay, reserve capacity in the sense it can be cleared that it is a generating station where the amount of energy generated by the power station will be ready in use, but it will be ready for the operation, but it is not in operation. Okay. And apart from that, our VPP incorporates controllable demands. Controllable demands in the sense, as I have stated earlier, our washing machine, our room cleaning robot, and also automatic dishwasher. These are the controllable load demands. Okay. With the help of our independent system operator, with the help of the DSM technology, they'll be sending signals. That means ICD technology. A signal will be transferred in such a way that these loads can be operated from a remote place also. Next one is parameters such as demand price elasticity and load recovery patterns as characteristics. Okay, and this VPP acts as a good solution for the controlling of renewable energy sources. Okay, another one is this VPP may contain photovoltaic, that means solar PV cells, wind power generating stations, small hydro stations, biomass, biogas, and combined CHP, combined heat and power generators. So these are the various kinds of power generators that we have already discussed earlier. This will be coming under VPP. And also, when RES is connected alone, this VPP will provide good and efficient results. Now let us go into the another section, that is distributed energy resources. These distributed energy resources scheduling can be done with the help of VPP. I have discussed this point earlier. And the next one is managing the load and scheduling of the resources. Okay, that means this topic will be generally coming across the technique, that is demand side management. That means in demand side management, as we all know that the generation follows load. But in DSM techniques, the load follows the generation pattern. That means depending upon the load, the generation varies. Here you can observe that. Here you can observe that the scheduling of load resources, scheduling of our loads can be managed. And also the next point is DER. It obtains energy from the distributed energy resources and contracts with consumers to supply the energy. The main objective is to maximize the profits. Okay, so here till this we will be getting the introduction of the VPP. Now the literatures for research will be going on. The first one is integration of various types of DER technologies. Okay, how this DER technologies can be integrated with our existing power system. So first DER technology means I have told that wind system, solar system, thermal power plant, biogas, biomass, all these kinds of power plants will be considered as a wind system. In this, the first topic is demand side management, and the next one is distributed generation, and the third one is distributed storage. Now let us go and tell about one by one. Okay, first one is demand side management. Okay, demand side management. I think I haven't kept any empty slide. Okay, let us draw a curve that is time for 24 hours, and this is load in kilowatt hours. Okay, let us assume this curve is of power demand and the next one this is the forecasted load. Forecasted load means we will be forecasting this load based upon the seasons and times and intervals. That means we will be forecasting this load one day ahead. Our motive is we should generate the energy in such a way that the power demand curve should almost meet the forecasted load. Okay, and the next one is distributed power generation. In distributed power generations, there will be solar panels, diesel generators, and with all these instant generating sources, we will be generating the energy and we will be interconnecting with these DERs. Next one, distributed storage systems. Here, the battery storage concepts will be getting into existence. The battery storage will be getting into existence. The battery storage, what it will does means it will stores the energy from PV cell and wind units with the help of converter inverter technology. It will be again converted into AC supply, and with the help of this, we will be selling our energy to the grid with less reduction in harmonics. Next one is implementation of demand side response programs. So mainly demand side response programs are divided into two categories. First of all, why we need demand response program? Demand response program in the sense we will be giving commands to our loads in such a way that we should earn more profits. Okay. So first one is price based program and the second one is incentive based program. In the price based program, we can see that time of usage. Okay. Let us take an example of a mobile. Our mobile may get charged from 0 to 100% with 60 minutes. That means this is the time of usage. This is a small battery with a capacity of 6000 mAh. If you take a battery of an EV, it will be in the range of watts. Okay. This EV battery, in order to get charged from 0 to 100%, it will take a time of around 2 to 3 hours. That means for charging only, it will be taken 3 hours. It means this is nothing but time of usage. Or else, this is in terms of charging consumption. Let us take another example, that is a fan. If you turn on the fan for 1 to 3 hours, let it be 3 hours. 3 hours, our energy consumption will be around 10 rupees kind of thing. Like that, or the project based program is directly related with usage. The usage is very high. If the usage is very high, the amount of consumption or the amount of pricing is also very high. Next one is critical peak pricing. Okay, critical peak pricing. Let us take the load curve. Okay, this is time in 24 hours and load in kilowatts. You can observe that the cost during off peak, that means from here to here and here to here, it is called as off peak hours. And this part is called as peak hours. If you observe this graph, during off peak hours, the electricity bill will be very less. And during peak hours, the electricity bill will be very high. So that's why here it is mentioned as critical peak price. During peak hours, the amount of electricity bill consumption or the electricity bill will be getting will be very high. And the next one is extreme day critical peak pricing. That means in a busy day, like festivals will be all in the home, or during festivals, all the shopping complex will be very busy. During that time, the load curve will be known as extreme day critical peak pricing. And the next one is extreme day pricing. It is also similar one. And the next one is real time pricing. Based upon the real time data, we will be pricing our we will be pricing or on the pricing mechanism. So this comes under, these are the techniques that are under price based program. And the next one is classical one. In classical, there will be two methods. First one is direct control and the second one is interruptible curtailable program. So in direct control method, we will be directly turning on and off the loads in the manual condition. That means manually we will turning off the loads when they are not used. And during uninterruptible curtailable program condition, that means we can't control those loads, especially in the types of industries. Not to shut down a system or load, it will take some time. So those things will come under classical control approaches. And the next one is market based. So in market based, the first one is demand bidding. Okay, that means several companies will be there. As I have told earlier, the generation companies and distribution companies, there will be any number. For example, in Andhra Pradesh, we will be having AP Transco, AP Disco, and AP Genco. Whereas in Telangana, TS Transco, TS Disco, and TS Genco. That means transmission company, distribution company, and generation company. Let us have a distribution company with the D1, another distribution company with D2, another distribution company with D3. Okay, if you observe this, another let us take time also here. So let us take 0 to 4 hours and 0 to 4 and 12 to 16 hours as off peak off peak, and remaining hours means 4 to 11, 4 to 12, and 16 to 24 as peak hours. Okay. Now during this time, person, that means the distribution company D1, they can charge 10 rupees per unit, and this person may charge 100 rupees per unit, and this person may charge 20 rupees per unit. That means based upon your demand, you need to take the energy from a respect to distribution company, which is nothing but demand bidding. Next one is emergency DR. This emergency DR, that means based upon your emergency, you will be getting the price. DR means demand response. Next one is capacity market. Like if the amount of energy is more with us, we can get less amount of prices during off peak hours. That means less amount of income during off peak hours. If the capacity we are having is very less, and if we can sell that energy during peak hours, means we will be earning more amounts of profits. And the next concept is ancillary market services. Here the ancillary services, in the sense, we can go for battery storage systems. Various kinds of battery storage systems are available in the market. So based upon based upon its capacity and storage levels, we can sell the energy or we can store the energy in such a way that our electricity bill may be reduced, and also we can earn more profits. Okay. And next concept is uncertainty analysis. Uncertainty means we don't know what will happen. This is meant by uncertainty. So in general, the uncertainty in our BBP is of 9 types. First one is knowledge uncertainty. By mistakenly we have forgot something. That kind of things will come under knowledge uncertainty. And the second kind of thing is model uncertainty. Model uncertainty, in the sense, we have will be considering our transfer function model of the system. There may be some there may be some wrong values are placed in time values or gain values. This will be coming under model uncertainty. Next one is parameter uncertainty. So our transfer function model is having some parameters. If we taken the parameter values as wrong, that will be coming as, that by mistakenly the parameter values are wrong, it will be called as parameter uncertainty. Next one is natural variability. Naturally, the uncertainty will be occurring this thing. And temporal, by temporarily. Spatial, that means spiritually. Decision uncertainty. That means all of a sudden we need to take some decision, but we didn't take in that decision, or by mistake we have chosen another option. So this will come under decision uncertainty. And the next one is goal objective. Our main goal is to reach or to earn more profits from the grid. This is one of the major goal of the VPP virtual power plant. And the next one is values and preferences. So these all are some of the uncertainties. And it is followed by multi-objective optimization for economic dispatch. First thing is, here you are supposed to know about optimization first case. Second one is economic prospective, and the third one is objective, whereas fourth one is multi-objective. Let us discuss in detail. First one is optimization. Okay, this optimization is of two types. First one is of minimization case, and the second one is of maximization case. Minimization case, in the sense, the error values are to be minimized. For this minimization, errors and losses. Losses, in the sense, or transmission line losses or distribution losses, those losses can be minimized. And maximization, in the sense, the values such as profits or the electric vehicle charging station values should be get profits. So this can be done with the help of optimization techniques. For optimization, many techniques such as meta-heuristic techniques, such as crow search, particle swarm, artificial ABC algorithm, PS algorithm will be existing. So we can use any of these techniques in order to gain the minimization case or maximization case. And the second one is economic. Economic, in the sense, in terms of price. Price. Okay. Price. How we can optimize the price? maybe we can earn more profits. How more profits will be getting? By selling our energy to the grid. And the second one is losses should be very less. That means the transmission line losses or the amount of losses that are being generated and distributed should be minimized in such a way that automatically if losses are minimized means the amount of power generated will be transferred to the load in an efficient manner so that we will be getting more profits. So this comes under economic. Next one is the third one is objective. In order to perform the optimization techniques, there should be some objective case. There should be one objective. In our VPP, that means virtual power plant, our objective is to earn more profits. Suppose if we go to the yesterday's topic, there the objective is to minimize the errors. And previous day classes, if we observe, means to minimize the error. There are also control systems we have discussed it. In that part also, our motive is to minimize the error. Whereas yesterday, our motive is to minimize the frequency and type of deviations. But whereas in today's topic, our objective is to maximum utilization of renewable energy sources with the help and to earn more profits. So this is our objective. Next one is multi-objective. So generally objective function may be of one objective function. If objective function is of one kind, only one element is of single objective. If two objective functions are mixed, that means if two or more than two objectives are mixed, then it will be called as a multi-objective function. Here I have given an example of power generation, fuel cost generation. So if you observe this one, fuel cost is the first objective function, that is F1, where it is given by sigma I is equal to 1 to Ng. Ng means number of generating stations. Here it is a fuel cost. That means AI plus BI PGI plus CI PGI square, where I is 1 to number of generating stations and A, B, C are the cost coefficients. Okay, let us take some break after some time. Okay, welcome back to our session. Now we are discussing about multi-objective function. In the multi-objective function, in the multi-objective functions, there will be more than one objective function. Here, the fuel cost is the first objective function and the emission of carbons is the second objective function. So if you look into this first function, fuel objective, that is, it is given by fuel cost F1 is equal to sigma I is equal to 1 to Ng. Now we are discussing about multi-objective function. The multi-objective optimization function, there will be more than one objective functions. Here for this problem, we have considered two objective functions. The first objective function is fuel cost. The fuel cost is the first objective function, and the second objective function is emissions of carbons is the another objective function. So if we look into this fuel cost function, it is given by F1 is equal to sigma I is equal to 1 to Ng into AI plus Bi into Pg plus Ci into Pg square, where Ng is number of generators. It may be 1, 2, 3 or 4, any kind of thing. And AI, Bi and Ci are the fuel cost coefficients. And this one Pg, here Pg, it is a power generated value, power generations. So our objective is to minimize the fuel cost. So this is the first objective function. Whereas coming to second objective function, it is denoted with F2 and the sigma is equal to 1 to Ng and I plus Bi into Pg plus gamma I into Pg square plus omega I into e power mu I Pgi. Here also AI, beta I, gamma I and mu W are the cost function coefficients and Pg is the power generator. So this is first objective function and this one is the second objective function. Our main motive is a multi-objective function. So by adding both the functions, this is also minimization case and this one also minimization case. So here we have developed an objective function, that is minimization of f1 plus f2. That means here we have generated a new function, that is f as a new function, that is the combination of fuel cost function and emission functions which are to be minimized. For these objective functions, there will be some equality and inequality constants. Let us assume that equality constant is power generated is equal to power demand plus load. This is the equality constant, and inequality constant is this PGE. Let us assume three generators. That means I is equal to 1, 2, 3. So the PG1 can generate a power in between 10 to 20 megawatts, and PG2 can generate a power between 20 to 40, and PG3 40 to 60 megawatts. Okay, but the thing is, this PG is given by PG1 plus, PG2 plus, PG3. Let us assume it is 100 megawatts. Okay, so this is equality constants, and these three are inequality constants. So these are examples of equality and inequality constants. So as a multi-objective function, we are supposed to minimize this objective function, which is fuel cost as first objective and emission as second objective, with these constants, equality and inequality constants. So next one is strategic bidding in energy markets. How the bidding goes place. So in order to get these things, we are supposed to go through the conventional market. In conventional market, there is only one way of centralized market. Sorry, in centralized market, there is only one way of exchange of information. That means one way of transfer of energy. Okay, that means a monopoly exists among the generation, transmission, distribution markets. Whereas this PVV, PVV here, there's many number of, there is n number of generation, distribution, and transmission companies will be there. Here, so you can observe it. This is generation companies, which are generally known as Gencos. Here, transmission companies, generally known as Transcos, and this is distribution companies. So these companies are operated by an operator called independent system operator. That means this ISO, he provides bidding and also provides rules and regulations for the transfer of energy from generation, transmission, and distribution to the customers. Here a power exchanger will be there. This power exchanger exchange the power between generation and transmission companies, and this energy service company, it is a company which will look into this generation and transmission companies. So if you observe this part, this is the energy flow. Here the energy flows from generation to transmission company and transmission to distribution company, and from distribution company this energy passes towards customers. Whereas this two-way line is an information exchange. That means communication exchange being taking place. So how the communication takes place? The communication may be two-way information between power exchanger and generation companies. And here also you can look into it, you can observe it. Between generation and transmission companies, there is a transfer of there is a communication exchange. Even generation and distribution companies, even generation transmission, generation distribution also, there will be a transfer of communication exchange. Even between the customers and consumers. That means here the consumers may get energy from the distribution company, or the consumers may supply energy to the distribution company in such a way that huge amounts of profits can be generated. So this is about strategic binding. That means bidding. Sorry, bidding. That means at what amounts of price, if we sell, means we will be getting the maximum energy. It will comes under bidding part. Next one, virtual power plant. There are two types of configurations. First configuration is technical virtual power plant configuration, and the second one is commercial virtual power plant. So in commercial virtual power plant, it participates in the energy markets. That means this CVPP, it deals with energy market biddings. And whereas this technical VPP, that means CVPP, along with that means it performs the operations of CVPP, that means commercial virtual power markets, that is of participation in energy markets. And it also provides balancing with ancillary resources. That means In CVPP, only market will be there. And in TVPP, market plus battery storage systems, which are nothing but ancillary services. These ancillary services will be considered in the technical power plants. Okay. Now let us go in detail of about technical virtual power plant. Okay. The main function of technical virtual power plant is it provides integration and coordination of multiple distributed energy resources. Earlier, I told that distributed energy resources means a group of energy resources. It provides the coordination among the multiple energy resources, and also it integrates new energy resources to the DER, that means distributed energy resources. And also, apart from this coordination integration, it also integrates energy storage systems with controllable power system. That means it have the controllable loads in the power system. As the example I stated, the dishwasher, washing machine, room cleaner, these are all comes under controllable loads in a power system. And next one is advanced software and communication technologies. So what does the communication technology says? The communication technology transfers the data, especially in this virtual power plants. A two-way exchange of two-way transfer of data will be there. And with the help of advanced software, we are aggregating. That means we are aggregating the group of energy resources and monitoring the energy generated by the energy resources and the load consumption, and also the equipments of a virtual power plant. And also optimizing the optimizing path in such a way that maximum amount of power is generated to the load, and also maximum amounts of revenue is to be generated with a wide range of energy resources. Here the DPP consists of solar panels, wind turbines, batteries, and electric vehicles. Here in this also electric vehicles are also considered. The next point is this technical virtual power plant. It provides stability. In general scenario, during peak hours or sudden rising disturbances, our system loses stability and it oscillates from its nominal values. Whereas with the help of this DERs, nothing but distributed energy resources, our system may regain its stability and also improves its reliability. And flexibility is also improved to the power system. That means with the help of this DERs to the conventional power system, stability, reliability, and flexibility will be improving. And next one is it helps to maintain balance between the load and the supply. And also this VPP provides energy and participates in energy markets and offering aggregated energy capacity and ancillary services and demand response programs. Apart from that, this DER provides owners to get benefit from their assets by gaining profits. This is about the technical virtual power plants. Next one is commercial virtual power plants. As I have told earlier, the commercial power plants always deals with market strategy, and whereas the technical virtual power plant, it deals with commercial power plant plus battery storage systems. That means ancillary storages. So that's why in the previous slide you have observed, you have came across energy storage systems, nothing but ancillary source, and somewhere here you came across electric vehicles. This is also one of the ancillary source. Okay. These are the ancillary sources. Next one is commercial virtual power plant. In commercial virtual power plant, it is defined as a virtual power plant and is used to integrate and optimize multiple distributed energy resources to a single coordinate system. That means here all the DRS will act as a single system and coordination will be there in between them. It is a centralized unit. Next part is a centralized unit and it controls diverse sources of generation storage. And coming to the key aspects of commercial virtual PPP, commercial virtual power plants, first concept is aggregation. Aggregation in the sense it combines all the power generating capabilities of various DERs, that means distributed energy resources. Here it stated that it integrates and optimizes multiple DERs as a single unit. Here aggregation means that point only. That means various DERs acting as a single unit and in a single pool of resources. Next one is optimization. Here we are doing optimization in such a way that with the help of advanced algorithms and real-time data, we are performing optimization techniques in order to predict the load forecasting in the upcoming days or predict the load amount of power generated in the future and also to earn more amounts of profits by selling the power, or to reduce the amount of transmission and losses in the previous multi-objective function kind of thing, reduce the amount of losses in such a way that huge profits can be extracted. So this comes under the optimization part. Next one is grid stability and reliability. So how this happens? So earlier in the conventional power system, whenever sudden deviation occurs, our system loses its stability. So in order to regain the stability, we are introducing the DERS. DERS means distributed energy resources, nothing but a group of power plants. This we can this example this for this I have given example in the objective number 3 of virtual power plant. Okay, so this grid stability can be gone up to ramp ups also. Next one is ancillary services. As I told that ancillary services means the electric vehicles or battery storage devices. This helps to improve frequency regulation, voltage control, and also balances the reserve powers to the grid. Next one, energy trading. Sorry. Sorry. Energy trading means we are trading energy as a single entity so that buying and selling will be taking place with the DERS and such a way that the maximum optimization of energy will be strategies considering the maximum revenue generations for the DER owners. Next one is demand response management. Previously, I have told you that demand response algorithms, which is nothing but demand response management only. This is capable of using demand response programs by flexible managing loads and adjusting energy consumption based on the price signals, which helps in reducing the peak demand. That means with the help of this demand response case, I have told you this graph, isn't it? One is forecasted, another one is mm, actual load demand. So our forecasted load, our load demand should match the actual forecasted load in such a way that demand side management techniques will be taking place with the help of demand response management techniques. So here you can see the components of a virtual power plant. Here, this is the virtual power plant. Okay, it is a combination of power systems, power storage devices, power generation devices. This is the power generation devices, and this is the power storage devices, and this is the consumer part. I think this slide is similar to first slide, but here we'll be finding a difference. So see here, the amount of power that is being generated by wind, solar, biomass, biogas, geothermal, and hydro is all comes under a case called DER, nothing but distributed energy resources. Okay, here distributed energy resources, there will be an interconnection between them. That means there will be a communication among all the things, and this will act as a single utility. After that, this distributed energy resources, this control group is there. This group controls, that means gives command for the system which station, which generating station should be turned on, or else which generating station should be turned on, or else which generating station should act as a reserve capacity. Like that, this DER will sends command signals with the help of this IoT technology, Internet of Things technology. And apart from that, this is a conventional power system where two-way exchange of information will be taking place with virtual power plant. And here also you can observe that the power storage systems. The power storage in the sense you can know that battery storage systems. So here battery storage system is provided. And apart from battery storage devices, it's electric vehicles. Nowadays, this electric vehicle technology, we will be considering this as a battery storage system. Okay, because the electric vehicles works on the battery. The major component is battery itself only. So for that purpose, we will be considering the electric vehicle as a battery storage systems. Apart from that, battery storage systems such as hydrogen fuel cell, water heat pump, and fuel cell system are also considered. That means here these are some of the examples of power storage systems. Apart from this, as we have discussed earlier, ultra capacitor, redox flow batteries, flywheel mechanism, SMCES. Okay, these are some of the examples of battery storage devices which will store energy, and depending upon the type of application, these energy storage devices are utilized. And coming to the consumer parts, okay, in consumer parts, I have told you that three types of consumers will be there. First one is commercial consumer, second one is industrial consumer, and the third one is residential consumer. So these three consumers, okay, let us take this is a school or college or industry or anything, is a smart one. Smart one in the sense on its roof, solar PV panels are installed or else wind turbines are installed in such a way that the power is generated on our household appliances also. And here also the two-way communication exchange between the DER will be taking place. Here, this consumer will be storing energy during off-peak hours, and during peak hours, they will be selling energy to the power system. So during peak hours means the electricity bill consumption during peak hours is very high. So during high peak hour, during high pricing hours, this smart appliances home or industry or college, even our college is also selling energy. Okay, this energy will be selling to the grid so that we'll be earning profits. Another one is CHP, combined heat pump, combined heat and pressure. This is also one of the kind of generating stations or thing. So this is about the components of a virtual power plant. And in detail, we will be going through one by one further. So first one is distributed energy resources. As I told earlier, you can see it's a decentralized energy station such as solar panels, wind turbines, fuels, batteries, small scale power plants will be considered. These are typically owned by the individual participants. That means even though these are installed at a particular house, they will be acting as a single unit, but they are individually owned. Suppose in my house the solar plant is installed, so I am the owner for that. In other house, some other plant is installed, he is the owner of it. So that's why they are typically owned by and operated by an individual participant. Next one is communication and control system. With the help of IoT or ICT technology, that means sophisticated communication technology, a real-time monitoring of data exchange will be taking place among different DERs and energy management systems. The third one is energy management systems. So energy management system is a central software platform that is used to integrate DERs with VPP, and they can work with smart meters, weather forecasting, and uses advanced optimization algorithms to optimize the operation of virtual power plants. Okay. And the next one is demand response capabilities. If you observe this one, some capabilities will be there for the demand response. So this one includes enabling its activity it to an actively management and use flexible loads within the system. Okay. As I stated earlier, this is one of the major capability. That means in our house, some controllable or flexible loads will be there. These flexible loads will be are supposed to be operate at off peak hours instead of peak load hours. So this is one of the demand response capability. That is the thing, but flexible loads are to be operated at off peak hours. Next one is advanced analytics and forecasting. So this one is, as you observe that analytics. Analytics means it deals with some kind of data. The data may be of forecasting data, power generation data, load consumption data, or load pricing data, or load mechanism data, any kind of data. It deals with the analysis with the help of some sophisticated tools. And the next one is forecasting. Forecasting means predicting the data. So see, you can see this now. To predict the energy supply and demand patterns, and also to optimize the SS dispatch and to provide accurate revenue forecasts. Okay. Next one is market integration. Our DERs, that means distributed energy resources in virtual power plant, are to be integrated with markets to provide frequency regulation and access capacity reserves and helps in balancing the grid power and to provide economic benefits to the participants. Next one is cyber security measures. As all the distributed energy sources are interconnected one another, the cyber attack may happen. So in order to in order to protect against these cyber threats, some cyber security measurements are to be taken. This includes authentication protocols. That means if you give the protocol, then it will operate, or else it won't be operates. So these are some of the protocols. The next one is encryption and monitoring systems, intrusion detection mechanisms. These are utilized to provide the confidentiality of a virtual power plant infrastructure. Okay. Next one is classification of virtual power plants. Previously, we have discussed about two types of virtual power, that means two different kinds, and this one is the classification. So coming to the classification, the first classification is centralized control virtual power plant. Second one is distributed control virtual power plant, and the third one is fully distributed control virtual power plant. We will be looking into one with detail. So we all that controlled virtual power plant means it's a virtual power plant with which controls will be there. And centralized in the sense there is only one way exchange of information transferring data from the generating to consumers. Okay, only one way exchange of data. Whereas coming to decentralized virtual power plant, there will be two-way communication exchange of data, and also the consumer can be able to sell and receive the energy from the grid. And it is also automated and fully distributed in the sense it is completely automated based upon the programming techniques, based upon the artificial intelligence techniques. Our system is completely and fully distributed, will be coming under fully distributed controlled virtual power plants. Okay, here you can see the energy management techniques. So if you observe this part, this is the structure of energy management systems, and here the flow chart of energy management systems you can observe it. So first we will be going through the structure of EMS. Before going to this structure of EMS, let us find out the components of EMS. So if you observe this one, CHP, that means combined heat and pressure, and this is the external boiler where steam is to be generated, and this is the industrial zone. That means industry. Let us assume it as industries, and this one is the desalination plant. Desalination plant in the sense it converts salt water into fresh water, and this is the wind park where electricity is generated to the wind systems, and this is the utility. That means the grid part. This part is PV power plant. That means the power that is generated by the solar PV systems, and this one is a smart city. Okay. Now let us go in detail of energy management systems. So energy management system is a technique where the energy that is generated by the power plants or distributed energy sources is to be managed in an efficient manner. So if you observe this one, here the energy is being generated by the wind park as 1, PV power plants as 2, and here see boiler, that means thermal power plant. So energy is being generated by the 3 different parts. So see, you can see the arrow mark, first arrow mark, second arrow mark, and third arrow mark. And also we'll be getting energy, we'll getting the energy from the utility. That means grid also will be getting some amount of energy. So these 4 sources, first one is thermal, second one is wind, third one is solar, and the final one is grid utility. So you will be getting energy from all these things, and it is being utilized by, see, industrial zone. That means here I have considered industrial consumers. Next one, utility, household appliances. And the next one, desalination tank. That means we are we are managing the energy in efficient manner. So in order to get detailed explanation, we are supposed to look into the flowchart diagram. So let us go to the flowchart. So in the flowchart, you can observe that at first instant, we are supposed to capture the data, that is power demand. Okay, that is power demand means here in this case the power demand is in this city is one power demand, and desalination plant also it requires power, and this industrial zone also requires power. So power is being required by 3 parts. First one is city, second one is desalination plant, and the third one is industrial zone. Okay, so see, if there is surplus power, that means if you are generating more amount of power, that means actually we are not generating more amount of power. The energy generated will remain constant throughout the load until unless with the help of renewable energy sources. So with the renewable energy sources, we are generating more amount of power. That means we are supposed to check the condition. So let us check the S condition and no check condition. First, let us go for S condition. If the energy that is generated is more than the required amount of energy required, then we will see the PDER, that means distributed energy resources plus PEL, that means electrical resource. If it is found to be S, we are reducing the amount of energy generation by CHP. That means more amount of energy is being generated. Instead of reducing the generation energy from renewable energy sources, we are trying to reduce the energy from our thermal power plant with the help of boiler. So we are reducing because the thermal power plant will be having some minimum and maximum ranges. Okay, so for that purpose, we are reducing the amount of energy being generated by the thermal power plant. Okay, we got it here. And after that, if there is any excess amount of energy, we will be driving that energy to desalination plant. So drive this energy to desalination electrolyzer. Okay, okay. Next, we'll again come back here. If the amount of energy generated is not more, then we can directly give this energy to desalination power plant. From here, we will be going to the optimization technique. Okay, this is for the S path. Now let us go for the no path. In no, if there is a power deficit, that means if you need more, if more amount of energy is required, then you can generate the energy from, then you can buy the energy from the grid. Did you get it? So here, see, if surplus amount of power is there, it's okay. If power is not there, then there will be power deficient. So in power deficient, you are buying the energy from the grid. So this is the grid, and you are buying the energy from the grid. Okay, and after that, even after buying energy, if there is power deficient, means you are selling, we are giving this energy to this desalination plant because it works with less power. If no means, that means if there is no deficient power means we will be stop the least gainful industrial power. That means we will be reduced cutting off one industrial zone, and after that we will be going for the optimization techniques. So like this, the energy management technique will be going first. Ultimately, the thing is, the desalination plant is having the lowest energy consumption, so it will be giving to this plant, which converts the salt water to mineral water. Next one, what is the difference between VPP and microgrid? First of all, we need to know why microgrid came into existence all of a sudden, because till now we are talking about virtual power plant and conventional power plant, CHVPP, THVPP, commercial virtual power plant, technical power plant, and all the things we have discussed, decentralized, fully decentralized, distributed kind of thing. But all of a sudden we came across microgrid because it looks, the microgrid and virtual power plant looks both are same, but in microgrid there will be only a single entity, whereas coming to VPP, number of multiple entities will be there. So first let us go to the definition of microgrid. A microgrid is a small local energy grid designed to operate autonomously. That means it is a grid. It will generate small amount of power to the small local community which operates autonomously. That means individually it will be operating. Whereas virtual power plant is the combination of multiple sites. That means multiple generating stations are combined and will work as single utility. Here only small energy will be generated with small entity. And here it is privately owned by an electricity infrastructure. That means a microgrid is owned by a private company. But whereas here this VPP, it is centrally controllable and maintaining independence. That means even myself also I can operate this VPP. Okay. Next coming part is it microgrid helps by decentralizing energy generation and store to improve the reliability. Whereas the VPP delivers, okay, coming to this part, this microgrid is a decentralization concept will be occurring here. And microgrid provides an opportunity to generate additional revenue. That means here the what amount of energy we are generating, we can sell this energy from the microgrid to the grid so that we can generate energy. Whereas here also, this VPP delivers many benefits. Here only additional revenue we are getting, but with the help of this DERs, that means this VPPs, first one, lower cost for energy use will be getting. Okay, reduced emissions, that means carbon emissions can be reduced, and enhanced assets control will be taking place. Optimization can be done, and also additional revenue can be generated. Whereas in microgrid, only revenue can be generated. Coming to the PVVs, here we will be getting, we will be reducing the use of carbon emissions. Low cost for energy is also getting. So this is the major difference. That means in a VPP, microgrid will be there, but microgrid can't be a VPP. That means virtual power plant. Next one, the assets of virtual power plant and microgrid. So here you can observe that. First, let us go to this one, microgrid. As I stated earlier, this microgrid is a control system. It consists of traditional grid, and depending upon the real-time data, okay, weather, energy, pricing, signals, and requests, we are operating the microgrid. Here in the microgrid, centralized network will be there. And in the microgrid also, energy storage devices will be considered. Okay, energy sources and energy services will be there. Getting my point? In microgrid, it is connected to a traditional power grid where it works with real-time data, and it belongs to a small community where small amount of energy can be generated and revenue can be generated by selling energy to the grid. And also it contains energy sources and energy services will also be provided in the microgrid. Whereas coming to the virtual power plant, here both generation, storage and load management can be taking place. Whereas in microgrid, only generation and storage, but load management can't be happened in microgrid. Okay, so if you observe this one, in virtual power plant, this load forecasting data will be there. That means real-time load forecasting data, which is readily available in the microgrid also. And also, here it is also centralized, there is also centralized. Here market interference will be there in virtual power plant, whereas in microgrid market interference won't be there. If you observe this one, here microgrid is there. Okay, this microgrid means nothing but this entire system will be coming under this virtual power plant. Previously, I told you that microgrid is a part of virtual power plant, but virtual power plant is not a microgrid. That's why here a microgrid, site A microgrid is coming under the virtual power plant. And similarly, site B and site X. Okay, that means here in virtual power plants, we are considering controllable loads also. Apart from that, generation, storage, and load management techniques, heating and cooling techniques, EVs are also considered in the VPPs, that means virtual power plant virtual power plants. So, in order to brief overview of this, you can say that this microgrid belongs to a small community with small amount of energy generation, that can be utilized with the help of this real-time forecasted data. Whereas coming to the virtual power plant, this microgrid will be coming into the virtual power plant, and also the controllable loads and the market interface will be coming with number of transmission companies and distribution and generation companies will be increasing. That means market players will be coming in this also. Whereas market players won't be here. Only one particular entity will be here. A number of individual entities will be there. Next one is research. Why on what topics the research on virtual power plant is to be carried? The first part is RES installation on household sites. Maybe you people have heard less people have heard about the word net zero energy buildings, NGEB. That means net zero energy building. That means this building is taking zero energy from the supply, from the grid. Instead, this grid is generating energy, and the households in this building are getting supply from this technique, and they're selling energy to the grid. Did you getting it? Net zero energy building is one of the prominent topic in this virtual power plants. Next one is influence in the power system in active manner. That means how this virtual power plant is being showing its influence on the power system. And third one is distributed system operators. How the operation taking place, how the control technique taking place, especially the help of GPS technology, GSM technology. Apart from this, how the monitoring taking place, these things, and how the cyber security threats can be detected. This is one of the scope for the virtual power plant. And this here I have mentioned three main focuses. First one is feasibility of distributed energy resource for market participation. And the second one is virtual power plant control and coordination optimization. And the third one is design of virtual power plant and its power system. So these three are the main focuses of research in our virtual power plant. Next, we came to a study on VPP. One of my friend who is working in this area has worked on this one. This is one of his article. The objective of this work is fuel cost minimization of a conventional power plant through economic emissions dispatch, considering wind and solar powered hybrid system. That means the main objective of this system is here, along with conventional power plant, that means thermal power plant, renewable sources such as solar and wind are considered in such a way that economic emissions dispatch are to be reduced. So the system is tested with IEEE 30 bus system, and the system consists of 4 conventional generators. That means 4 thermal generators, 4 in number, and solar plant of 1 in number and wind farm of plant 1 in number. Okay, and it is done with for a load demand of 283.4 megawatt system. So if you observe this one, my main motive is along with conventional power plant, I am integrating renewable energy sources such as wind and wind and solar in such a way that the economic emissions can be reduced. For this, I have considered 30 bus system, 4 thermal systems I have considered, 1 solar and 1 wind systems considered. The load is around 293.4 megawatts. Okay. For this, some data sets will be there. The first data set is a windrows diagram. Okay, windrows diagram in the sense windrows diagram in the sense in which angle we are getting maximum amount of energy. So if you observe this part here 0 to 30, 60 like 360 degrees. That means 0 to 360 degrees, the wind tower can be able to rotate. So if the wind turbine is in which rotation, you'll be getting maximum energy. We'll be discussing it. See here, this is blue in color, green in color, and somewhere yellow is also there, and somewhere light green is also there. So mostly you can observe the green and blue colors. If you observe the blue color part means 20 to 25 meters per second is the wind speed. That means at 0 degrees, you will be getting a wind power of about 20 to 25 seconds and 0 to 330 like that. So in this range, you will be getting 20 to 25 meters per second. After that, the green color part, this completely green color part, you will be getting a wind energy of 5 to 10 meters per second. Okay, that means this is the pie graph which we are getting. This is the rose diagram which we are getting in what direction and what inclination the amount of wind velocity will be. Okay, and this is taken at the Salt Lake, Calcutta. Next one is solar radiation. Solar radiation means for solar power plant, the input will be the solar irradiation. Whereas for wind power generation, wind farms, the input is wind. Like that, the solar power plant, the input is solar irradiation. So here we have taken the irradiation, calculated irradiation from January to December. That means in a year we have calculated, and the average solar radiation at various places, that is Ahmedabad, Bhopal, Chennai, Delhi, Calcutta, and Mumbai are calculated and are found to be this one. And the work is carried out in Calcutta part, because the wind turbine, the wind farm work is also on Calcutta Salt Lake, and this is also at Calcutta itself only. So for this will be the average solar irradiation for the year. So these are the mathematical modelings. First one is modeling of a solar power plant, where phi is solar irradiation and P is the power generated by the solar PV panels. And this one is modeling of a wind farm. F of V means wind velocity and P means wind power. So it has some constants. The wind power will be less than wind will be 0. If it lies between V into V rated, it will be P rated by something. P rated into V minus V in by V rated minus V in. If it lies between V rated to V output, then the output will be V rated. If it is the wind power is greater than V output, then it will be the V means velocity. Do you getting it? If wind power will be 0 in the cases where it is less than V output and it is V less than V output. Okay, these are the inequality constants of wind turbine systems. So here we have got it by using probabilistic gamma distribution curve, where tau is this is gamma, and this is probabilistic modeling using variable distribution. So for this, I have considered the mathematical modeling, where fuel cost emissions and emissions have to be minimized. This one I have explained it earlier. So I have presented the results here. So if you observe this one, without virtual power plants, we have drawn the convergence curves. So first one is particle sum optimization. Second one is a BAT algorithm. Third one is artificial bee colony algorithm and CSO algorithm. Such optimization technique or CSO. So if you observe these things, on the x-axis, we have considered total cost. That means total cost that is generated in dollar per hour. And on the y-axis, these are iteration. That means number of iterations. Similarly, this is the convergence plots with virtual power plants. And same algorithms we have considered. First one is PSO, second one is BAT algorithm, third one is ABC colony algorithm, and the third one is CSO algorithm, OCSO. So, and this is with without virtual power plant, and this is with which virtual power plant. Here the best convergence we are getting at with the blue color on OCS, so that is around 560 here. Okay, and similarly here if you observe this one without virtual power plant, it is greater than 650. Sorry, it is less than, it is greater than 645, around 647 kind of thing, $647 per hour. So from these two responses, we can, it is clearly observed that with virtual power plants, our system is converging very quickly. That means with virtual power plants, our system has shown significant improvement in stability. Okay, that means within less time, our system is getting to stability. Our system is regaining its stability conditions. Next one is conclusion. So coming to the conclusion part, the emission of fossil fuel power plants, uh, the emissions from the fossil fuel power plants used to be reduced. This is one of the major conclusion. And the second one is the fuel cost and emission minimization problem to VVP is considered in this work. Third one is the concept of environmental virtual power plant considering wind PV renewable system is proposed. And the results demonstrates that the fuel cost decreases with the VVP integration and in a high penetration of renewable energy sources. And it also can be noted that the uncertainty handling is also considered, and in most of the and very few works have been considered with this uncertainty handling. So this may be considered as the for the future works in which we can generate more number of articles. So I think with this my presentation has come to an end. If anyone has queries, they can ask us, or else you can text it in the chat box, and we'll be replying in the chat box itself.